In this video, we are going to be going over a bunch of different types of statistics and probability questions that you might see on the ASVAB. And in order to do that, we are going to be using my website called mathmaven.co, that is mathmaven.co, and a link to that will be in the description below. So to start off, we're just going to go ahead and click on practice. And then we're going to go to settings, and we're going to deselect everything except for stats. And then we'll drop the questions down to, let's say, 16. We'll do 16 questions for this video here. And then before we actually begin, I want to remind everyone that the only way you are actually going to get better is if you actually try these problems out yourself. So I'll read the question, I'll ask you to pause the video, so you can pause the video, actually try and work out the solution on your own, and then press play. We'll go through the explanation together, see if you got the right answer, and just move on from there. Because again, I can't stress this enough, the only way that you are actually going to get better is if you actually practice these problems on your own. So with that out of the way, let's go ahead and get started. Question number 1. What is the median of the following data set? All right, so look at these numbers down here and try and figure out what the median is. So go ahead and press pause and try this one out on your own. All right, so hopefully you attempted that one. Let's try and go through this together here. So the median, remember, whenever I see the median, I always try and think of the middle number. All right, the median is just the middle number. So I'm going to copy all these numbers over here. And then one common method that people tend to do is they will go and just rewrite all the numbers in ascending order. They're just going to sort all these numbers here. On the ASVAB, you kind of have limited time, so that might take a little bit longer. Another easier way to do it would just be like actually crossing the numbers off as you go. So for instance, I'm going to find the biggest number here, which in this case happens to be 75. And I'm just going to cross it out. And then I'll also cross out the smallest number, which happens to be negative 29. And then I'll keep on doing that. So next biggest number is 71. Let's cross that out. Next smallest number is negative 18. Let's cross that out. Next biggest number is 40. Nope. Next biggest number is actually 62. So let's cross that out. Next smallest number is negative 8. And then let's see, we got 44 and then 17. And there we go. That leaves us with 35. 35 should be in the middle there. That is our median. So we will select 35, check the answer, and it turns out to be correct. So we will move on. All right, next question here. Question number 2. If you roll a standard 6-sided die one time, what is the probability that you will roll a 1 or a 2? All right, you roll a die one time. What's the chances that you are going to roll a 1 or a 2? So go ahead, press pause, and try this one out on your own. All right, let's go ahead and work through this one together now. All right, so this one actually has 2 different events here. All right, these are going to be two different mutually exclusive events is what this is called. All right, and the reason is they're called mutually exclusive because you can't have them both happen at the same time, right? Like we can't roll at one time and have it be a 1 and a 2. It's either going to be a 1 or it's going to be a 2. They can't happen at the same time. We only get one roll here. All right, so for the formula for solving 2 mutually exclusive events here is going to be the sum of both of those events. All right, so what does that mean? Well, what is the first event? The first event is the probability of rolling a 1 on a 6-sided die. What is that? All right, if we are given a 6-sided die, well, we are given 6 sides, and only one of those sides is a 1. So that is going to be a 1 out of 6 chance. All right, our second event is the probability of rolling a 2 on a 6-sided die. And again, it's 6 sides. So there's only 6 possible numbers, and on that die of 6 possible numbers, only one of those numbers is a 2. All right, so only one of them is a 2. And now because these are mutually exclusive events here, we are going to add these together. And pretty much anytime you see an or in one of these type of statements, you know that you're just going to have to add them. All right, usually it's or. All right, or is usually associated with a plus symbol when we're talking about probability. And then whenever you see problem statements with and, then you'll know that you most likely need to multiply. All right, since we have an or statement here, we are just going to add these. And since the denominators are already the same, it's just as simple as adding just the numerators. So 1 plus 1 is going to be 2, and that will stay 2 over 6, or simplified, that will be 1/3. All right, so we have a 1 in 3 chance of rolling either a 1 or a 2. Well, if we look at all of our answers here, we actually don't have a 1 in 3 chance, but we do have 33%, or about 33%, which is the same as 1/3. So we will go ahead and select that answer, and it turns out to be correct here. All right, so let's go ahead and move on to the next one. Question number 3. If you randomly pick one card from a standard 52 card deck, what is the probability that you will pick a 3 of spades? All right, so press pause and try this one out on your own. All right, let's try and work this one out together here. All right, so if there's 52 cards in a deck, all right, 52 cards, total possible cards that you can choose from, well, only one of them is the 3 of spades. All right, so there's only one 3 of spades in this entire 52 card deck. So that is a 1 out of 52 chance. And it should be as easy as that, but if we look over on our answer sheet here, we don't have 1 over 52, but we do have a couple different percentages. So our next step then is to convert this fraction here into a percentage, and the way we can do that is with some long division. All right, so we're going to take the denominator, which is 52, and put it on the outside, and then we take the numerator, put it on the inside, and then we ask ourselves, how many times can 52 go into 1? Well, that's going to be 0, which means we need to get some decimal places here. All right, we'll add some fake zeros at the bottom. 52, how many times can that go into 10? Well, again, that's still 0. So let's add another 0. 52, how many times can that go into 100? Well, that will be 1. 1 times 52 is 52. And then we subtract. That's going to give us, that's going to give us 48. All right. We could say, how many times does 52 go into 48? It doesn't, so then we need to drop another 0 down here. And then we could ask ourselves, how many times does 52 go into 480? But we really don't even need to go that far, because we can already see, if we look at our answer sheet here, we are going to end up with 1%. Or probably a little bit greater than 1%. And the only answer that would make sense at this point is going to be this 1.92%. So we could probably just go ahead and say that that is going to be our answer there. We will check the answer, and it happens to be correct. 1 over 52 converted into a decimal, or into a number, is about 1.92%. All right, so let's go ahead and move on to the next question here. Question number 4. Mackenzie took 7 tests with the following scores: 64, 89, 69, 100, 71, 94, and 80. What is the mean of Mackenzie's tests? All right, so press pause and try this one out on your own. All right, let's try and go through this one together here. So again, we see the mean here, and we should remember that the mean means the average. We're really just looking for the average here. To find the average of anything, you're just going to add up all the things that you have together, and whatever the sum of that is, you will then divide that by how many total items there were in general. All right, so let's see, we have 1, 2, 3, 4, 5, 6, 7 tests here. The question even tells us we have 7 tests here. So we are going to add up all these numbers together and then divide that sum by 7, and that should be the average of all these 7 scores. So let's go ahead and work through that together now. We will say 64. We'll say 64 plus 89 plus 89. All right, that's supposed to be 8 there. Let's see, that'll be a 13, that'll be 15, so we're at 153. Let's add 69 in here. All right, that'll be a 2, that'll be a 2, carry the 1, and that's a 2. All right, we're at 222 now. Let's add, let's see, 100 here. All right, that one's pretty simple. That's just going to be 322. All right, let's add our 71. All right, that'll be a 3, that'll be a 9, that'll be a 3 again. Let's add 94 now. And that'll be a 7, that'll be an 8, carry the 1. We're at 487. And now let's add our last test here of 80. That'd be a 7, 6, 1, carry the 5, or carry the 1, 567. All right, so we now have 567. We're going to have to say 567. Divide that entire thing by 7. I can't do that in my head, so now we're going to have to use some long division again. Again, we take the denominator, put on the outside. The numerator goes on the inside. And then we ask ourselves, can 7 go into 5? No, it cannot. All right, can 7 go into 56? Yes, it can. It can go in 8 times. Because 8 times 7 is 56. Subtract, we get 0. Drop the 7 down. 7 can go into 7 exactly 1 time. So our answer is 81 here. This is an average of 81. So we will select that one, check the answer, and it happens to be correct. All right, so we move on to the next question here. Question number 5. Oliver has a box of marbles consisting of 3 orange marbles, 3 red marbles, 10 purple marbles, 4 yellow marbles, and 3 green marbles. If Oliver randomly picks one marble from the box, what are the chances that the marble will be green? All right, so press pause and try this one out on your own. All right, let's go ahead and work through this one together here. So there's a lot of words in here. These paragraph ones, sometimes it can get a little bit confusing and, just a lot of things being thrown at you. Really, it helps sometimes just to sort of reread the question. What are the chances that the marble will be green? So right there, that's going to tell us pretty much almost everything we need to know. We are looking for the chance of it being a green marble. Well, we see there are 3 green marbles possible, right? So if he's going to reach into this box, he's going to have an option, a chance of getting 3 marbles that are green. All right, so, well, then how many total marbles are there? Well, let's see. We just need to add up all the marbles together here. So we have 3 marbles. We have 3 orange marbles plus 3 red marbles. That's going to give us a running total of 6 marbles so far. And then we have 10 purple marbles, so we're up to 16 marbles now. And then there's also 4 yellow marbles, so now that's 20 marbles. I'm going to pop us up over here. So we have 20 marbles now. And let's see, that was the 4. And then we have 3 green marbles. All right, so the total amount of marbles in this box is 23. All right, there are 23 total marbles here. So there is a 3 out of 23 chance that Oliver will pick a green marble. But again, if we look in our answer sheet, we don't have the option of 3 over 23. So again, we need to use some division here. So we're going to take the denominator, again, put it on the outside. All right, throw the numerator on the inside. 23 can't go into 3, so we'll say 0, add some decimal points. 23 can go into 30 one time. 1 times 23 is 23. Subtract, we'll get 7. Drop a 0 down. 23 can go into 7. That'll be 3 times. 3 times there. 3 times 3 is 9. 3 times 2 is 6. All right, we will have 1 left over. And we could keep going, but we can see we're going to be at about 13% here. And if we look at our answer sheet, we have 13% right here for option C. So we'll just go ahead and check that answer. And yeah, it turns out to be correct there. So we will go ahead and move on. All right, question number 6. What is the mode of this data set? Press pause and try this one out on your own. All right, so let's go ahead and work through this one together here. Whenever I see mode, I just like to think of most. All right, mode means most. What they're asking here is what number appears most often in this data set here. All right, so I like to do kind of like tally marks with this. So I just go through each number and I'll put a little tally marker next to each number that I see. So I have a 9 and I see that 1 time. All right, I see an 8 1 time. We have a 13 that I see 1 time. Next one is a 9. So I'll put another tally next to the 9. Next one is a 13. So I'll put another tally next to the 13. And then we have an 11, which I see that twice in a row there. We have another 9, so put another check mark by the 9 or another tally by the 9. Put another tally at the 13. We have a 7 here. We have another one for 13, another one for 13, and then we have a 10. All right, and I went through all the numbers here, so now we'll just look at which one is the most here. Well, clearly 13 appears 5 times in this data set, so go ahead and select that one, and that turns out to be the correct answer. All right, let's move on to the next question here. Question number 7. If you roll a standard 6-sided die 2 times, what is the probability that you will roll a 5 the first time and then a 3 the second time? All right, so press pause and try this one out on your own. All right, let's work through this one together here. So this one's asking us about the chances of rolling some die a die, and trying to figure out if it's going to be 5 and then a 3. All right, we roll a die 2 times, and what's the probability that the first time it is a 5 and the second time it is a 3? All right, and I think that keyword "and" there should give a pretty big clue, because again, remember, or, when we see "or," that usually means that we are adding the different different probability of events here. And then when we see "and," we are going to be multiplying the probability of the events. All right, so this time we see an "and," so we are going to be multiplying the different events here. And what are the events? Well, the first event is the probability of rolling a 5, which the probability of just rolling a number is going to be 1 out of 6, because there's only one 5 on a 6-sided die. And then it's going to be multiplied because, again, we have this "and" here, the probability of rolling a 3 on a 6-sided die. And again, that's just, there's only one 3 on the die, so that's going to be 1 times 6. And then since we are multiplying fractions, it's just as simple as multiplying the numerators and multiplying the denominators. So 1 times 1 equals 1, 6 times 6 equals 36. All right, so we have a 1 in 36 chance of getting this here. That doesn't appear to be anywhere on our answer sheet here, so we need to do a little bit of division again. All right, so 36 goes on the outside. Our 1 goes on the inside. 36 can't go into 1, so we're going to need some decimals here. 36 can't go into 10. 36 can go into 100. What is that, 3 times probably? Nope, that'll only be able to go in 2 times, all right? So 2 times 36, 2 times 6 is 12, carry the 1, 2 times 3, that'll be 72 there. All right, minus that, that'll be 28. All right, drop another 0. And then we could actually probably even stop here because we know it's going to be 2%. It's going to be about 2%. And if you look at our answer sheet, B is the only one that's going to make sense here at this point. So we'll go ahead and just select B, and there we go. And we see the explanation is the exact same when we have two independent events, or when we see the "and," we should know that we are going to be multiplying the probability of each event. So both events in this case are 1 over 6, so we're just going to multiply 1 over 6 times 1 over 6. Comes out to 1 over 36, which is equivalent to about 2.78%. All right, so let's go ahead and move on to the next question here. Question number 8, what is the mean of the following data set? All right, so press pause and try this one out on your own. All right, let's go ahead and work through this one together here. So again, they're looking for the mean. The mean just means the average. They just want to know the average of these 4 different numbers here. So we're just going to say 20 plus 22. That's going to equal 42 plus 67. That's going to equal 109 plus 3 is going to give us 112. All right, and that is just as simple as saying 112 over 4. Let's see here. Well, 100 divided by 4 is going to equal 25. We have 12 left over, and 12 divided by 4 is going to equal 3. All right, so then our answer should be 25 plus 3, which will be 28. All right, so 28 should be the mean or the average of these numbers here. So I will select C, and that turns out to be the correct answer there. All right, so let's move on to the next one here. Question number 9. If you randomly pick one card from a standard deck of 52 cards, what is the probability that the card is a 7? All right, so press pause and try this one out on your own. All right, let's go ahead and work through this one together now. All right, so we're randomly picking one card from a deck of 52 cards. So we know that there are a total possible cards of 52. All right, and then how many cards are a 7 card? Well, how many 7s are in a deck? A deck of cards has, again, 52 cards or 4 suits in a deck where a 7 card will be inside each suit. So we know there's going to be 4 7s inside of a deck. There are 4 possible 7s to choose from inside a deck of 52 cards. And this can be simplified a little bit. We could divide each one by 4, and we will get 1 over 13. All right, so that is a 1 in 13 chance of picking a 7. Again, we don't have 1 in 13 in our answer sheet here, so we do need to use a little bit of division again. All right, so 13, the denominator goes on the outside, the numerator goes on the inside. 13 cannot go into 1, so we'll do some decimal places here. 13 can't go into 100, but 13 can go into, 10, but 13 can go into 100. How many times could that go in? That could go in probably only 8, I would assume. And actually, looking at our answer sheet here, it's probably going to be B here. It's probably going to be 7, actually. So let's assume it's 7. 7 times 3 is 21. 7 times 1 is 7, plus that 2 is 9. So that's a 91. So yep, that actually makes sense here. So we know it's going to be about 7%. That sort of just verifies it there. So we'll go ahead and check that answer. And there we go. All right, so we can see a lot of times long division, like, I know it's no one's favorite. Long division sucks, but there's a lot of times where you can kind of just like do at least a little bit of long division and then use some, constructive reasoning to try and figure out what the actual answer is going to be. So like you can kind of, take shortcuts here or there, as we've seen us do a couple times with this long division already here. So let's go ahead and move on to the next question here. Question number 10. If you randomly pick one card from a standard deck of 52 cards, what are the odds that the card is red? All right, press pause and try this one out on your own. All right, let's go ahead and try this one together here. Again, we are going to be picking one card out of a deck of 52 cards. So we have 52 total possible outcomes. How many successful outcomes are there? Well, how many red cards are in a deck? Well, we should know again, there are 4 suits in a deck where 2 of them are red and the other 2 are black. So that means half of the deck is red, or half of 52 is 26. And then again, I just said half, so we can just kind of realize that 26 goes into both of these, and we can reduce this or simplify this down to just 1/2. All right. And we see 1/2 is an answer here. That is answer D. So we'll go ahead and check that one. And yeah, it turns out to be right. That was one that was hopefully a little bit easier by this point. Let's go ahead and move on to the next one here. All right. If you flip a coin 5 times, what are the chances that it will be heads all 5 times? All right. If you flip a coin 5 times, what are the odds, or what is the probability that it is going to be heads all 5 of those times? All right, press pause and try this one out on your own. All right, let's work through this one together here. Again, this one is a case of where we have independent events here. We have 5 independent events. And this one doesn't actually say and or, so it might be a little bit confusing trying to figure out like, oh, well, do I need to add all these different probabilities here, or do I need to multiply them? But let's try and think of it here. All right, we want to know what are the chances that it will be heads all 5 times. So that means the first roll the first flip, it needs to be a head. It needs to be heads. The second flip also needs to be heads. The third flip also needs to be heads, right? So if we were to say like the first flip is heads, or the second flip is heads, or the third flip is heads, right? If we were to try to use ors in there, that just wouldn't make sense, right? Because the question is asking, what are the chances that all 5 will be heads? So it's we can kind of just sort of assume that this is an and question, right? The first one needs to be heads, and the second one needs to be head, and the third one needs to be heads, so on and so forth. So this is an and problem, and again, with an and problem, we are going to need to multiply all the different events together. And what is the probability of just one event? Well, what's the probability of flipping a coin? All right, a standard coin has 2 sides, and what is the probability that it could be heads? Well, only 1. There's only one way it could be heads, if it lands on heads. The other way is if it lands on tails. So there's a 1 out of 2 chance of it landing on heads one time. All right, so we need to multiply this 5 times. So 1/2 times 1/2 times 1/2 times 1/2, and that should be 4, right? And then times 1/2, all right? So that's what it's going to be. It's going to be 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Well, all the ones up here multiplied together, that's just going to be 1, all right? So that's going to be 1 over something, and that something is going to be the product of all of those, all right? So 2 times 2, 2 times 2 equals 4, times 2 equals 8, all right? Times 2 again, this is our fourth 2 here, that's going to be 16, times our fifth 2, which will be 32. That is going to be a 1 out of 32 here, all right? 1 out of 32 chance that it will be heads 5 times in a row. And we see that as option A, so we will go ahead and select that one, check that answer, and it turns out to be correct. All right, so let's move on to the next question here. Question number 12. If you flip a coin and then you roll a standard 6-sided die, what are the chances that the coin will be tails and the die will be a 4? All right, so press pause and try this one out on your own. All right, let's try and work through this one together here. This one's actually pretty similar to the last one. Again, we have 2 different events here, and they're not dependent on each other, so they're independent events, and it's asking what are the chances that the coin will be tails and the die is a 4. All right, so we just have 2 events that have different probabilities, but we still need to multiply them together. All right, so let's start with the first event. What is the chance that the coin will be tails? Well, that's going to be a 1 out of 2 chance, and it's going to be times the probability that the die is a 4. Well, that is going to be a 1 out of 6 chance. All right, so we just have 1/2 times 1/6. Well, 1 times 1 equals 1, 2 times 6 equals 12. So this is a 1 out of 12 chance that if you flip a coin and then roll a die, 1 out of 12 times that coin will be a tails and the die will be a 4. We see that as option A here, 1 out of 12. We'll check that answer, and it turns out to be correct. All right, so let's move on to the next one here. All right, question number 13. If you randomly pick 2 cards from a standard deck of 52 cards, what are the chances that you'll pick a queen of diamonds and then you'll pick 8 of clubs? Without replacement, meaning like once you pick that queen of diamonds, you are then immediately going to pick 8 of clubs. Or once you pick the first card, you're immediately going to pick the second card without putting that first card back inside the deck. All right, so press pause and try this one out on your own. All right, let's go ahead and work through this one together here. Again, we should be looking for that keyword "and" right now, so we should know that we are going to be multiplying these 2 different events here. And, well, what is that? What are the 2 different events? The first event is picking a queen out of a 52 deck card, or the queen of diamonds, rather. All right, so that'll be a 1 out of 52 chance. And now, hopefully, you didn't try and multiply that by a 1 out of 52 again, because we need to look at this keyword here without replacement, meaning when we pick up that first card, we are not putting that back inside the deck, meaning the second time we pick up a card, we now have 1 less card, so it's now out of only 51 cards. All right, so this is a case where this is actually considered dependent events. We've used the term independent events previously, meaning the outcome of the first event had no effect on the outcome of a second event. Like, for instance, flipping a coin, right? It doesn't matter what the coin was on the previous flips, because that's not going to affect anything on future flips. But in this case, with this picking the 2 cards without replacement, the outcome of the first event does affect the second event, again, because we're taking 1 card from this 52, meaning there is now 1 less for us to pick that second time. So it's now times 50, or it is over 51 cards instead. All right, so with that out of the way, now it's just a simple multiplication problem. Multiplying these 2 fractions here, 1 times 1 is going to give us 1 on top. 52 times 51. I can't do that in my head, so we'll do some scratch paper down here. Give myself a little bit more space. 1 times 2 is 2. 1 times 5 is 5. Drop our 0 for the tens place. 5 times 2 is 10. 5 times 5 is 25, plus the 1 is 26. And then we add, that's just going to be 2652. All right, so that's 2,652. All right, 2,652 will be our final answer, which happens to be answer D right here, 1 over 2,652. And there we go. So that seems to be the correct answer with the explanation as such. All right, let's move on to the next one here. All right. Question number 14. Maya took 5 tests with the following scores: 100, 100, 86, 98, 90. If Maya takes another test tomorrow and wants an average of 96 on all 6 tests, what score does Maya need on the test tomorrow? All right, so let me just sort of reread that a little bit slower here. Maya took 5 tests. All right, the scores of those 5 tests are shown right here. And then she's going to take another test tomorrow, meaning that will be the 6th test. All right. She wants an average for all 6 tests to be 96. So if she wants an average of 96, what does she need on that test tomorrow? All right. What score does she need on the test tomorrow? So press pause and try this one out on your own. All right. Let's go ahead and work through this one together here. So again, we are looking for the score that Maya needs tomorrow. All right. What we have is the average, and then we have some of the tests that she already took also. So we're going to have to use a little bit of algebra here with our formula for calculating the average in order to figure out what score she needs. Because the score she needs on that test, well, that's going to be sort of used in with these other ones, right? Because what is average again? Average, well, we know that average is 96. All right, 96 is going to equal the sum of all tests. I'll just put sum of t here, sum of all tests for t, divided by the total tests that she took, which was 6. All right, she took 6 tests, or she will have taken 6 tests after she took that last test, right? So, well, what is the sum of t here? What is that? Well, that's going to be this 100 plus 100 plus, what else? We have 86 here, plus 98 plus 90, all right, plus x, plus the test that she needs to take tomorrow. All right, it's a little bit sloppy there, but hopefully you can see that it's the sum of all of these tests here, including the one that she will take tomorrow. That's what's going to be the average, divided by 6. That's what's going to be the average for all 6 of those tests. So we can just kind of do a little bit of algebra here and solve for x. That's what we're looking for. We need to solve for x. All right, so first thing, we should probably simplify all of these here. So let's see, 100 plus 100, that's going to be 200. 200, let's go with the 98 right now, so it'll be 298. Let's add in the 90 after that. All right, that'll be an 8, that'll be an 8, and that'll be a 3. And now let's go ahead and add in that 86 here. All right, 86. All right, that'll be a 4. All right, that'll be, what is that? That's a 7. There we go. So it is 474. All right, so we have 474 plus x divided by what? 6 here, right? Yep, 6 total tests. That whole thing is going to equal the average that she wants of 96. All right, so now it's just, again, basic algebra problem. Let's multiply this by 6. That way the 6's cancel out. Whatever we do on one side of the equal, we need to do to the other side of the equal. So multiply this by 6. I can't do that one in my head. So 96 times 6. That's going to be 36. That's going to be 54. 54, so 57 here. All right, so we now have 474 plus x equals 576. And now it's just, again, solving for x. Subtract the 474 from both sides. Those will cancel out. Subtract 474. And that's going to leave us with a 2, 0, so a 102. So x equals 102. She needs a a little bit of extra credit on this test in order to get an average of 96. She needs a 102, which happens to be answer D here. We will select that one, check the answer, and yeah, that turns out to be the correct answer there with the explanation, with all the explanation as such here, very similar to what we have done already. All right, so that one was a little bit trickier. Hopefully you got that one. If you need to press pause or rewind and rewatch it again, if anything wasn't clear or maybe it could have been explained a little bit better, drop it in the comments below. Let me know how we could have maybe explained that one better, or maybe I can create other videos really focused around this type here, because I will admit this one is a little bit trickier to sort of figure out on your own. But let's go ahead and move on to the next one here. All right, question number 15. All right, question number 15. If you roll a standard 6-sided die one time, what are the odds you will roll a 2? All right, so press pause and try this one out on your own. All right, let's go through this one together here. Hopefully by this point, this one's a lot easier than the other one. So again, we're going to roll a die one time. What are the odds that we land on a 2? All right, there are 6 possible sides. Well, only one of those sides is a 2, so we only have one possible successful outcome off of this event here. So that's just going to be 1 out of 6. 1 out of 6 is option C. We'll go ahead and select that, check it, turns out to be correct, and move on to the last question here. All right. Last question, number 16. If you randomly pick one card from a standard deck of 52 cards, what are the odds that the card is suited hearts? All right, what are the chances that you pick up a card that has hearts on it? All right, press pause and try this one out on your own. All right, let's work through this one together here. Again, we're going to be choosing a card from a standard deck of 52 possible cards. Well, how many of those cards are hearts? Again, a deck of cards is split evenly into 4 suits, so it's really just going to be 13 cards possible, or just 1/4 of the deck is hearts. All right, so it's going to be 1 over 4. You have a 25% chance of picking up a card that is hearts. So we go ahead and select A here for 1/4, check the answer, and that turns out to be correct. And there we go. We can go ahead and finish here and view all the results here, view all of our explanations and everything else. So I hope this video had helped. If it did, please do like it. Please do consider subscribing. Comment down below which ones you liked or didn't like. And again, also look in the description for a link to my website here called mathmaven.co. All right, this website allows you to pretty much just study a whole bunch of different types of math problems, and what I really love about it is not only the fact that it gives you explanations right there, but also that you can retry different types of questions here. So like with this one here, if maybe you got this one wrong the first time, you can just retry it using different values every time. All right, and you can see the answers change. So it just kind of helps you test a little bit more. So it really makes sure that you know and understand the information. All right. We also have a test feature on here, which is sort of like a timed test. And we can see there's a timer going on and sort of the same thing. This one doesn't happen to give you the explanation or the results until you actually finish with the entire test. But that's my website, mathmaven.co. It's free to use. You don't even need to sign up and enter an email and remember some stupid password or anything else. You literally just type in mathmaven.co into your browser and go and start practicing. And yeah, I hope that is a very good, valuable resource to you to help you get the best score on the ASVAB as possible. So again, please do like and subscribe, and I'll see you all next time.